All right. So yeah, so this is, and by the way,
Historical
we should be
maths.
writing the unit beside it, eh? Because I told you that when you go to some uh, course, you're gonna have to write beside it, and that would add up to be six
67.
seven 197
67.
pounds. All
Excuse
right.
me, sir. I have a question.
Mm-hmm.
Um, not relating to what you're doing right now, but the tutorials that we're going to be doing in general, are you going to use them for any form of grade or it's just for art and practice?
Well, they have structured the course in such a way that I can actually give a grade. I have to come up with my method of doing that. So what I will do, um, I am going to come up with a system to grade. The system. So I probably from next week on, I will have a question that we work in class, and I may let me see how I do this one now. I am going to have to make some groups. Um, and the groups that I'll probably do need to make, I'll probably have to make them with via the tutorial group. So the via the tutorial groups, I'll make some groups within those classes, and you all work into group, and based on submission of workout and willingness to participate, I can allot those marks. So I'm gonna come up with a little system because and why it is very, very important that student practice. What I see tend to happen, students come to class and they want, so that grade, so two grades that is going to be important for you. Your quiz grade, right? And your quiz grade and participation grade. So I'm gonna come up. Now that you're saying it, I'm gonna sit down and plan a little thing with your assignment. So I'm gonna give you some assignment. And remember, I said before, if I don't do it even for next week, I'm gonna plan it. Because what I want to do is I need student participation. And if I just allow you to come to class, not doing anything, I cannot give you those grades. So what I'm gonna do though, I'm not gonna make it be individual. I probably do it by group. All right. So I'll assign some question that student must work out. And then now, um, after a certain amount of, so we have what now? We have 10 units or 11 units. I could choose to say take
Question?
7 questions per group. And then now from that, I'm able to come up with um you based on your solution and on what you work out and your willingness to share, we assign each group a grade. And at the end of the day, I tabulate that and assign a mark, let's say a certain percentage of the mark, whatever percentage I decide for homework grade. All right, so homework graded mean that when you come to class, you come to class and participate. Because what we tend to find happening, and I think the person who wrote this, Dr. Campbell and others, they would have realized that students don't like to come to class and do any work. They want to come to tutorial for the lecturer to work the tutorial question again, and they are fine with that. And then when they don't understand, they run around and complain. So I think that it was a systematic a very planned approach for, and then I'm going to have to use it. I think I should use it because it's really a tool to help to encourage students to practice the subject matter. This subject matter, and let me say it again, and I want to say it on recording, that students need to practice. If you don't practice and commit at least 7 hours per week, you are going to fall behind with this course. This is a very technical course. What we're doing here now is just a little bit of prep. This is not the core. So, I mean, you're not necessarily going to be tested on as test on this part, but you will use it throughout the course in answering different questions and so forth. So it is important in that aspect. All right. Any more question? Does that answer your question, answer?
Yes, sir.
All
So
right, cool.
it's So the tutorial when we're doing it in the group, it's not attempt based, but it actually has to be 100%.
It come again?
As in, are you grading the tutorial based on attempt by the group, or are you grading it based on the answers actually being 100% right?
I would grade them on attempt
Okay.
and
So
participation.
it's just participation based.
Attempt participation. If you're wrong, then we are all willing to go back to the question and look at the solution, look at working it the correct way and reinforcing understanding. So the objective is yes, I want you to work it correct, but two, you must also be participating. Because one, how are you gonna get the know if a problem is wrong if you don't work it? So 3/4 of the class generally do not look at the tutorial question before they come to class. They do nothing at all. But yet still, when they finish a unit, they are happy mad if they don't understand the unit, some of them. And they haven't done anything to understand the material. So this is a course like mathematics, which involves your total participation. And if you don't participate, don't expect to get anything out of it. Right? It is just plain and simple. So I think the persons who wrote it was very strategic in realizing that based on experience. Anyway, I won't waste any more time saying that. I think I've said enough already. We still have an hour, so we want to utilize it quickly. All right, so let's move on. So that would be your part B, right? What is the next part? And what they say they want the answer in now. So the answer is in pounds. Or they say SI unit. Answer in SI unit. How would you get that in your SI unit? That's what they said. How do you get that in SI unit? That means they want it not in pounds, but in what? What other unit you think they want it in? What's the SI unit for weight?
Kilograms.
The what?
It's grams or kilograms, sir? Which one?
Kilograms, sir.
Newtons.
Newtons. Newtons, because it's
Oh,
weight. Not
Newton.
true?
What?
Yes, sir. Yes, sir.
Right.
Newton, sir.
Pardon me?
Yeah.
Yeah, man, it's Newton you want. So what Newton, what is this, what is pound to Newton? Anybody remember the conversion?
Sir, it's 4.4482.
So 1 pound
Is
is equal to
4.4482.
4.4482. Right, that is what we gave you. So what is that then when you convert it? Everybody know how to convert it. You could actually write it this way and say if 1 pound is equal to that, then how much is 6,197? This is one way of doing it. And you cross multiply and get it. Or you simply write 67197 pounds times the ratio of it. So you divide, you see what 1 pound is really equal to 4.4482 newtons. So you divide that by 1 pound. All right. And then
So
you
we're not going to remember the conversion rates. So.
pardon me?
Do we have to remember the conversion rates?
Some things are going to be given on some you get some standard part on the exam. You don't have to worry about too much about that. There are some of them are going to expect you to remember. But yeah, but the basic ones. Listen to me, in the out there industry, you'll have all of this at your fingertips, so it's not a problem. We give you some of them. We'll give you formulas and all of that. We don't ask you to swat formulas per se. If you remember them, fine with us. But I give you quite a bit of them in exam. That is in exam. Cause now you can look them up. All right, so that's you would just multiply that and what you would get here. What would be your final answer there? So your answer would be 229, sorry, 298.9 kilonewtons. All right, that's what you would get. All right, so remember it was what four digit. You must write it down in. All right, that's what it says. 4 significant digits or figure. All right, next one. It says here now, determine the internal volume of the container in cubic feet. Everybody know that this is cubic feet and not cup feet or something that the class was asking me last night. I was wondering what they were asking me, but they actually misread it. Yeah. So that's how they write cubic feet. All right, guys. Sometimes it's written that way. So this is part C. Anybody want to tell us how you do part C? So you need the internal volume. So we know that volume is equals to area times what? Height.
Height.
All right. Volume is area times height, or length times width times height. Now so. All right. So what would you do it from there? So therefore you're gonna have to what they want the unit in, by the way. What did they say? In feet. So everything need to be converted to foot. So length. What's the length that we are given for the internal length? It's 19 feet, 4 inches and 1/8 inch. And that one I give you the first one. I'm gonna do the first one for you. So this is 9 feet plus 4 inches, right, plus 1/8 inches. So, but we know, what do we know? We know that 12 inches makes 1 foot, don't? So from that, you know your conversion factor. What's the conversion factor now? So it's going to be 1 foot divided by 12 inches, all right? All right, so inches will cancel inches. Inches will cancel inches. All right, and therefore you work out all of that. So this is 19 plus 4 upon 3 feet plus 1 upon 8 times, that's what, 90 something. All right. So what's the answer is that now, please, people? So therefore, you just need to work out the fraction of all of this. Where's my writer? Gone? Not writing. What is going on here? All right. So all right. So that is feet. So that work out to be what now, guys? 19 how much? 19 point. So that's 4 upon 12. Gives you like point. Come on. 0.333. So it's plus 0.33, right? Plus, what's the next one there again? 1 upon that. How much is that? No. That's supposed to be 6. Why did I get 8? Let me fix that. Why am I getting 8 there? Let me just fix that. It's supposed to be 6. Why did I have 8 there? 6. Come on. So, what the reciprocal of 96? How much is that now, guys? So you get something like 0. Let me erase all of this. Let me write it down the bottom. I'm gonna write them. I'm gonna go back to it and write it down so it's clear. So this one is so you have 19 plus point plus 3 plus 0.1 no 0.1042, something like that. And then now when you simplify that, what you will get? So it is plus 0.333 plus 90.
19.343, so
This is 19.343.
75.
You remember you don't reach your final answer, you know. You don't reach your final answer, so we want to 8. Is that 8?
Yeah.
How did I get
Yes.
8 here?
Yes, sir. 8 is correct. You can run it up.
Is 8, I'm checking. Is 8 if
Correct.
it's character? I'm checking if Yeah. So right. So you check it and make sure it's 8. It's supposed to run after. Or 7. Check out that figure. Is that 7?
7.
It's 8 or 7 it's supposed to run to. Check it because it look like it's 7.
7, 7.
7. But I'm seeing
7, 7.
different. All right, let me just fix that. It means incrementally you'll have to write out a lot of figures to get that. So it is 7, flat 7, right? Yeah. All right. And that is FT. All right. So you're gonna do the next one for me. So that was the length. What about the width? So the width is now going to be equals to, all right, we want to skip a page, skip a line. So the width now would have been 7 feet, 8.5 inches. So which can be say 7 feet plus 8 inches. You can put the double dash plus let me fix that. All right. All don't know. And then we go to what's the next part here now? Right. So you're gonna do the same thing like before. Conversion factor, 12 inches equal a foot. So it's going to be reciprocal of 1 feet upon 12 inches. Same thing, 1 on 12 feet uh, inches. All right, now you do the same thing. So here now you would have 7 feet plus so this is 8 upon and 12, but the inches cancel. So that left you with feet plus inches cancel again. Left you with 1 foot upon 24. Right. And then you work out those, and then your final answer, the final answer for that now would be what now? Like 7.70833 feet. That's what you all got?
Yes, sir. That's what I got.
Mm-hmm. And then the next one, which would be what now? Height. The height given was let me see if I scroll back the page. Height was 7, and let me write that one down. It to be come again. 7 dash 10 and what 7.30 inches. So you go and you put 7 feet plus 10 inches plus 7.30 inches multiplied by 1 upon 12 inches, 1 foot up there. Same thing with this one, 1 feet upon 12 inches. All right, inches cancel inches, inches cancel inches. So you're left simply with 7 plus 10 upon 12 feet plus 7 feet upon, how much is that big figure there? It is going to be 32 times 32 times 12, 384, 384 feet. All right, and you work out those fractions. Your answer you should get something like 7.85 156 feet.
155.
Pardon me?
155, sir. I do have that
1.56.
you have
You
that three
don't
up
get
that
that?
five.
You're not getting that. So when you do 7 into 384, you're getting something like let me see. Does this thing have the tool? Oh, it probably have the tool, but I can't do it. I can't do it. Is there a tool that does it? Trying to move something here. No, I don't know the tool to do it. Not with this software. All right. Hold on. No. I'm gonna rewrite this down here. So it is about 7.85156.
Oh, yes, sir. I got that, sir.
You got it now?
Yes, sir. Yes, sir.
Yeah, so just check the working. You should get something like that. Alright, you could break these down in fractions as you know. So it's your
Oh, no,
choice.
sir. I got 8.01 now.
What?
It's 7 plus 7 plus 10 over 12 plus 10 over plus 7 over 30. Oh, sorry, my bad.
Check it again. Check it again. Because remember, let me just
Yeah. It's 384. My bad.
so this is
Sorry.
7 plus 10
I got
divided
it now.
by
Sorry.
10 divided by 12. You get something like 0.8 3 feet. All of this is feet plus 7 upon 384. 7 divided by 384. So you get something like 0.018229166, and you add them, and you should get something in that ballpoint. All right, so now you have all of them in feet. Your volume now is going to be equals to length times width times height, which is going to be, the length we got was 19.3437 feet, and the width was 7.70833 feet times 7.85156 feet. All right, and therefore your answer for that, what's your answer? Answer supposed to give you something like 1171 feet cube, or you could write it as 171 cubic feet. All right, so that's the standard way you write it. You would necessarily see it right this way, you'd see it more right this way here. All right, that's how you would normally see it written. All right. So now you have the volume. What did they say you must work it into again? Let's look back to the question. The question says you are to find it in SI unit. Can you convert that to SI unit, please? How do you convert? All right, so that is part D. You must convert it to SI unit. So this is part D now. Let's add a page. Let's add a page. So you must convert it to SI unit now. So SI unit, so that would be part D. So D would be, so you have the volume, which is, volume is equals to 1171 cubic feet. All right. What do you need to convert it now? You need to go back to some standard form, eh? What standard form? What do you know about standard cubic feet? How much meter make a foot? So remind you now that 1 foot is equals to 0.3048 meters. Do you agree with that? So therefore,
Sir,
1
are you writing?
cubic feet is going to be equals to 0.3048 to the cube.
Sir, are you writing on the screen?
Pardon me?
Are you writing that on the screen?
Yes. Oh, sorry. It paused. I'm sorry. I realized it paused. So, okay. Where did I drop off from? You saw when I finished wrote this, right? Up top, when I finished part C, you saw this part?
Right, sir.
And
Yes,
then
sir.
I was saying that this now, the volume in D, because you want it in SI units. Right? So we go back to standard form, we know that 1 foot is equals to 0.3048 meter. So one cubic feet is equals to 0.3048 all cube meters cube. And that will give you what now? When you cube all of that, what is your so that will be 0.3048 cube. So you're getting here is 0.028368 meters cube. All right, so that's your conversion factor. So you can use our conversion factor now to do the conversion. All right. So therefore, it is going to be equals to 1171 cubic feet times 0.028 3168 meters cube upon 1 feet cube. And therefore, that cancel that, and you multiply 177 times that big figure there, 1171, and you should get 33.1 6. Everybody got that? Meters cube
Yes, sir.
there. Yeah,
Yes, sir. That's it, sir.
approximately there, approximately. All right. And then now the next part, what's part D again? Part D. Okay, part D now. Okay, you're not seeing that page. Let's shift back to our Zoom page. Where's our okay, so if you switch back here now, it will say to you, okay, it want the density. So we're gonna stop at density. I don't think we're gonna, oh yeah, we see how far we reach. We're at density. Let's pick off the next section that we need to do. Let me just I'm just pick off this part here. So it is right here. All of this is part the next section. So let's get back to the page. So we'd have done all of that, part D, and I'm gonna drop this right here, and we're gonna paste him right here. Gone too far. All right, I have a challenge with this thing, moving this thing. Okay, I think it's all right. I'm not gonna move it too far. Next thing, see it running away on me now. Well, let's see if I can get this thing come down. Oh, more like that. See if I can get it to move. Worse. Better or worse? Let's see. More like this. All right. Yeah, let's leave it right there. Oh, it's not looking good at all.
Sir, you could probably zoom it to a smaller size, 80% or
Hold on. Someone saying something?
no, no, so you could probably zoom it to a smaller size so you can see the entire screen.
Smaller size. How much of it here? Oh, there. I was trying to move it. I'm looking for the tool size selection. Oh yes, here it is. What is it I'm trying to select? Select rectangle. I'll see this one. Yeah, here we go. Yep. Smaller size. I'm trying to get it to come back. Oh, let me see if I can move it over. All right. Yeah. That's all right. Can see it a little better now, not true?
Yes, sir.
All right.
Yes,
But the last part that we were supposed to do, we did the density E. All right. How you gonna do the density now? The density.
I must over volume.
Yeah, the density now. How we gonna do the density? The density, they want the density. So your challenge is the density now. All right, so let's get back to it. So the density, we know density is equals to mass upon volume. Not
Volume.
true? All right, so we need to calculate the density now. All right, so
Sorry,
the
so,
density is the mass of the density will be the mass of the
container.
payload, and is what kind of density? They say the mass of the maximum of the content So is it what? It's a mass of the payload, not true? Versus the volume of the payload. Agree?
Oh,
Not
yes, sir.
true? Did we
Yes, sir.
calculate those already?
Yes, sir.
I don't think we calculate the mass of the payload, you know. We
The mass of
calculate
the
the weight of
payload.
the total container. That's all.
sir, I have a question.
What did we
Yeah,
calculate?
man.
Let's look back at it.
6,239,
Yeah, that
62,391 pounds for the payload.
6,200 and what? Let me see what we did.
Sorry, 62,391 pounds for the payload.
Oh, hold on. Yeah, so we did this. We will wait. So we had this. Yeah, we had that. The weight of payload, yeah. And then now, okay, so we need to find the mass of the payload. All right, so the mass of the payload, right, so I'm gonna have to give you a factor to do it. You can't do it with all information. You need there's a gap. You need the acceleration to gravity. So the mass now is going to be equals to what now? Mass of the payload is going to be equals to what now? Equals to the weight of the payload upon G. Right? But which G are we using? Because the thing is in pound, we cannot use meters per second. So you have to use a G that is in. So you have to use the value of the G. The value of the G that is relevant is saying that G is going to be equals to 32 point what is it now? 174, and it is in what? Foot per second square. That's the value of the G you use. You can't use 9.81 meters per second. You have to use feet per second. Right? And that is normally given. You could look it up. That's the value. I think I may have accidentally taken it out of this slide. Let me see. I don't think it's in the slide anymore. I may have accidentally. So we have this here, but the G probably inadvertently took it out. I was checking if it's anywhere in the notes. Not seeing it in the notes. All right, so that's why I'm giving it here. Pardon me? Because this is what is here. So this, we need to add the other one to it. I think I may have accidentally taken it out. All right, so yeah, let's go back to it. So yeah, so we have that now. Now you're able to calculate it using the correct one. So your weight here what you say it was again? It was 62391. That's the weight of the payload, right? And that's pound divided by 32.174, and this is what? Feet per second square. So you know that the mass is gonna come out to slug, right? You have been, I think we showed the unit slug before. So this is how we slug. So it is MP, which is the mass of the payload, is gonna be equals to what's that work out to? Something like 19. What you got for that? How much is that? And it's going to give you a slug. Because when you work it out, you're going to get what now? You're going to get pounds per second square divided by feet. Right? And that will give you a slug. So remember, that's what slug is. Where is the slide again? Slug is, where did we have that in the slide? Oh, see it here? Oh, where is it? Somewhere here. See it here? Pounds per second square divided by feet. Are you seeing what I'm showing you?
Yes, sir.
Right.
Yes,
So this is slug. Yeah. And the value. So right. So that is slug. You can use slug. So this you can just call it slug. So what we're doing with here now, this is gonna be scared. This is gonna come up. Remember, this is gonna invert. So the second square gonna come up beside the pound, and the feet is gonna come below. So how much is it get? How much you get for that?
1939.17.
Oh, I'm trying to find my writer. It's so fine. 1939
39.17.
0.17, and it is known, and so this is pounds per feet per second square, otherwise known as
Slug.
slug, which is slug, right? All right, so that is, so now you have found the mass. What else do we need to find? Because we trying to find the density, not true?
Yes,
All
sir.
right, so now that we have found that, now what about the volume? Did we have, oh, we have the volume already, so now we can find the density. So the density we already know is going to be MP upon VP. So MP is 1939.17. All right. Slug, if you choose to put it there, divided by the 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 volume. The volume, what was the volume we calculated again?
So, Rich, the cubic
One,
feet.
pardon me? VP. What was VP again? VP was this. Isn't it
Yeah,
VP this? No. Yeah.
that's
The
the
VP
third.
here. This is the VP that we need. We need it in this one. This is the VP that we're using.
All right, sir.
1171. Right? 1171. And it was what? Cubic feet. Right. So that is what we're using. And then what that will give you the density.
1.656. All right.
1.65
6.
what? 6, and that
Yeah,
is slugs
right.
per feet cube. All right. Okay. Last part of the question, it says space explorers plan to use the same container to store material on the moon. Even though a different environment, the permitted weight that the container can have remains the same. So the weight, I'm gonna make the weight be the same. They're gonna assume the weight is the same. If on the moon, determine the total mass of the container when carrying its maximum payload in SI unit. So they want the the maximum what they want. Carries maximum payload. Right. And this is, so you want the total mass. So what is total mass now? So that is part, what's part what? F, yeah. So that was E. Now D and E, E was the density here. So this would have been E, part E. And part F now, which is part F here. So part F, maximum weight it was, or mass. Maximum mass on moon. All right. How do you approach that? So it is, can somebody tell me how you approach that part? So you want to find MT. What is that equal to? We have mass of the payload, not true?
Yes, sir.
What is the mass of the container?
I tier something.
Okay, good. So we have those. So we need, so okay. So we need to do some calculation. Did we calculate them fully?
The mass of payload and mass of the
Yeah,
yes, sir.
right. So what and what? Did we work them out? Did we
Yes,
do
sir.
that?
I think that's the first thing we did.
First thing we did the total weight of the container, not true? Which is
Yes.
so the total weight of the container would have been equals to the total weight of the container, right? Upon G on the moon. That would give us the same thing. So yeah, so as you can remember, weight is equal to mg, right? Weight total weight. So the payload, pay mass times g. The transpose, so all of that would have been the total mass. You recall? So the total weight will give you total mass. Agree?
Yes, sir.
Let me just write that better. So it is weight total is equal to total mass times G. Right. So this is what we essentially have here. So it is the mass of the pillow plus container. So we have the total weight already, which you say we calculated as, what was this value again? Then we calculated, what was it? What did we calculate? Let's look back and refresh ourselves what we calculated. We got the total
Yes, sir.
well,
67.
where is it? Okay, so this was this 67. Right, so we got 67. Right. So 67, and then okay. And we had, right, okay. And on the moon now, you need to know G on the moon. But G on the moon is gonna be G different from right, so we need to get G on the moon. I need to give you that value. G on the moon, let's write that one down. Come on, right now. So G on the moon is a standard figure. It's gonna be equals to, I'll just put moon, equals to 5.33199, and it is gonna be in feet per second square. Right, so that is in second square. So basically, remind me the figure up here that you say it was again. It was what, 6 something?
197.
197
Yeah.
pounds.
No, not points. 67,197.
67197.
97 pounds.
Yeah, man. Upon G now, which is 5.33199, and therefore that works out to be 1 2 260 2.6 pounds. And this was, what's the unit here? It was feet per second square. So you know this has become second square upon feet. All right. So basically that becomes slug. So you could rewrite this as slug, eh? So this could be written as slug. How much slug you want to round it off to? Depends on what you want to round it off to. Am I having enough decimal? Let's say 1, 2, 3. So you could round, you could this now. What if you want to write it as 4 figure? You could write it off as 1260. Not true? Or 1, 2,
Yes, sir.
2, yeah, slug. Depends on what we got there. What was it? 1, 2, 3 slug. We can write off as slug. Right. So we take off 1 half of the 6. We get 3. So you can write this off as slug.
Sir, and that would make it 4 significant figures.
Uh 4 significant figure would be 1, 2, 3, 0. So okay. Right?
But 1 second, sir.
So what significant it should be, sir? 5,
Pardon me?
right?
How much did they
It's
say?
supposed to be
4, they said that we should have write it in?
Yes, sir. 4 6 weeks.
4. Oh, okay, all right.
I'm just checking on how many it was. All right. 4 sig figs, 4 sig figs. I have another answer that put in 5 sig figs here. I'm just looking at it. Okay. All right. Yeah. All right. Yeah. So some persons write this as the final answer, but if you're saying it's 4 sig fig, I write it as this one here. Hold on. Yeah. All right. That's that. All right. Yeah, the next part of the question, all right, you are going to finish up the balance here. You can just practice these. It says here complete, what it says here. Well, the first part, they tell us how much significant to write it in. Let me see. Does it says everything? Express your answer to 4 sig fig. All right. This part here may tell you something different. What it says 4 sig fig. So you can practice these. This is into what? SI units with engineering notation, no prefix. This one want engineering appropriate prefix, SI unit with significant notation, no prefix, and so forth. So you can work out these on your own. All right, so those we'll leave. So this is just a practice session, right? Just that you just practice it, but that's it. The relevance. Now next week we are going to move on to we're gonna move on to this unit here, and I will send you the solution to this So I will open a solution to this here. Now the tutorials that you may see on Moodle, I'm going to be changing up some of the tutorials. So no doubt I'm gonna show. Let me see. I may still use this one, but I'm changing up them to tailor how what I'm teaching. So this is so next week we should be on. So this is the tutorial for next week. All right. So this can remain the same. That's all right. I may change up the others going forward. So you'll get this question here. I may change up some of these questions, but for now, this is the set questions that I have for tutorial, and there's nothing wrong with these. These are quite good questions. So I'm going to look at Cartesian and 2D vectors resolution. So 2D, this is represent 2D, and then we're going to move to 3D. So hopefully this is what we're going to be doing next week. We're going to be doing 2D resolution of forces. Everything here, you notice the forces are applied at the point here, and it says here, so this is your tutorial, and I try and open it, say you must express the 600 Newton and 20 force in Cartesian vector form. So you will be able to write the 600 and this into Cartesian vector form. You must determine the resultant of the 600 and the 320 force and express that answer in Cartesian format, which is very good. So you must be able to do that. So that's the resultant of that one. So you're going to refine. So what we are saying here, somebody writing, please. This is so what you should be doing is finding the resultant of the 320 and the 600 separate, and then I say you're going to determine resultant of that and express that. Then next part you're going to express the force determined. So express the force determined in part B in terms of magnitude and direction, measuring clockwise from the negative y-axis. All right, so you're gonna do that. Then after that, you're gonna say if the resultant of all three forces is to be 800 newtons directed to the right, you must determine the magnitude of F and its directions theta. All right, so that is putting another spin to it. So you are going to pretend as if you just have two forces when you start out. You're not having F there, you're only having 325 and you only have the 600. So what you're going to do is draw a frame with those two forces, able to find the resultant of those two forces. So you would have known that the angle between for the 600, you'll see the angle that it has direction, it has force, it has a magnitude, and it has a direction. And likewise, you have the direction for the 325. So you're going to do that separate. When you finish that now, then you're going to combine that resultant, that force, along with F. And you'd have magnitude and direction of that resultant force. And then you are going to find F as a result of that. So it's a little bit of tweaking here and there will actually bring you through to understanding how to resolve forces. And then we're going to move swiftly to 3D vectors, which this one is going to be very critical. Let me see, did it ask for the coordinated angles? Let me see what it asks. It says you must determine the position vectors and determine RAC, determine the distance of B and A, determine the magnitude of CB, yeah. All right, so I'm gonna get a question put to this. Something with coordinated angles. So I'm gonna have to introduce coordinated angles. Probably I could probably use this question, or I do another one. Let me see. What could I do with this one? This is a nice question. I could spin it another way now. Ask a couple questions from this one. All right. It doesn't matter. I might switch this question. I may switch this question based on what so more likely I could switch this question and or ask some additional stuff on this one because I want to bring out some of the things that I wanted to principle that I wanted to understand. And this is look like a nice place for me to. This question is good as it is, but I can give an additional one. Right? I'll probably give an additional one for practice and all of that. And group work.
Yes, sir. When they post the PowerPoint for the
The
topics.
PowerPoint is you have the PowerPoint already? Didn't you? Are you seeing the PowerPoint for the class? Let me
No,
look.
it's not a model, is it?
It's not a model. Hold on. I'm sorry. I'm gonna check that now because normally I give you that before. Normally I give you that before. Where is this writer come from? Did somebody pick up a writer or is my writer? Where is this writer coming from? Oh, let me see. Oh, I accidentally touched it. All right, I'm gonna open it. I'm gonna check Moodle now. So you should be seeing it on Moodle. I don't know why. It's not typical of me not to. Hold on. Let me see if I can find it. So your Moodle. You should be seeing it. This is this course. This look like it. And so you should be seeing. You're seeing this one, right?
Yes, sir. I'm not seeing another one.
Let me see. Hold on. So that is a lecture. Hold on. Let me see. This is it. Yeah, I would open it before. Let me just check. Let me just check what. Let me just see whatever is here. Okay, so this is what I have here. Okay, this is what I have here. I was trying to amend it. I didn't do good amending it. I was trying to type it and correct. Yeah. All right. All right. Let me just get to just checking that to see what I actually have up on the site. All right. So then now the tutorial. So you have the first tutorial already, which is this one. It is open now. You can view that. Correct?
Yeah. Yes, sir. Topic 2 minutes talking, sir.
Okay.
When it's
Topic
explain,
2.
open as
Right.
it.
I am not going to open this yet. I'm going to amend it. Then I will put it back up. I'm going to amend a lot of what is right here. They're all here now, but I'm going to amend them. So I won't open it as yet.
All
All
right, sir.
right. So it means that I have some work to do. All right, guys.
Yes, sir.
So that is it for me.
So sorry for I missed yesterday class. It's 1866, right?
Come again?
Yesterday class, the face-to-face at 1866, right?
Yes.
Okay, well, I missed it. I just want to make sure. All right, thanks.
Yeah, you miss it. That's the lecture, and I did a lecture and I did a tutorial also. And I should be having another tutorial session with I think it's tomorrow. Yeah, sometime tomorrow.
Tomorrow?
I think I have another tutorial tomorrow. I'm almost certain I have another tutorial tomorrow.
Yes, sir.
What time?
It's on the. Hold on, let me look back at your Moodle, at the Moodle page. The Moodle page should have it there. It's all supposed to be there. If you look right here, you will see my times. Well, let's look at the Moodle page together. It should be right here. It's in the outline. I haven't changed a lot. Just put this right here. Let's just check what is here. So you will have it. So it is. So this is today 2 to 4. Oh, so it's 1 to 3 tomorrow. Face to face. I think it's the same room. I think so. I think it's the same tutorial lecture room. 1 to 3. All right. So if you can come that time, well, you come to tutorial today, so you don't necessarily. But if you miss a lot, And I don't think you miss anything too critical. You could simply read it, and if you have any issues, any question you ask.
Okay.
It's
All right. Well, I just want to catch up. I want to ensure I'm up to speed.
Pardon me?
No, I just want to make sure I'm up to speed, you know?
Oh, okay. Fine. So anybody you know that need to join, see there's a link here. So if anybody so see it right there. I will be moving the Zoom link that I have up today. I'm going to remove it because it is just started today. I don't want person to get misled by it. So there is a Zoom link. Where is it? See it right here for today's class, right down here. I'm going to remove it because it was just started today. So I hide it. It's gone. All right, I'll delete it. Yeah, I'll just hide it. All right, so that's that. Right. So shortly, when you're going to be, as soon as I'm up to speed, when you're going to be, let's say, having class, sometime I'm going to require you to log into Zoom and click on the Zoom link. But when I reach that page, I'll tell you that you just come in, and you look somewhere right here, and I'll put it up just like how I have the Zoom link there. You can't see it on your page, because I've hid it. So you notice it says hidden from student, so you can't see it, but I'll put it somewhere here and I'll show it, and then you will be able to just come in and click on it. First one now I'm sharing it in the WhatsApp group. All right, so yeah, they have upgraded the site a little bit, still working on it. So I'll wait on them for some of the other little adjustments. All right, guys. So I see you next week Tuesday again. I can actually open the tutorial from now, but the thing is I may change some stuff, so I won't open it now. All right. Next week I will update it. All right. All right, guys. Could you please type your name in the chat before? Oh, they have all gone already. Oh.
I'm here. What have a name in the chat?
No, right. They should have put their name in the chat for me to just keep a recording of all the attendees. It's a pity they never put their name in the chat. Just drop your name in the chat for the three you will left now. And that
Okay,
you
sir.
all right. Normally I ask persons to just drop their name in the chat. Once they're, well, the good thing is that some persons comment in the chat, so I would have anybody who said anything in the chat would have helped me to record persons, but I didn't do much chatting in there. Okay, all right, guys, see you next week.
All right, take care. All right,
Same
take care.
time, same place, online. All right, cool. All right.